So right now, let's welcome the second team, the Chinese University of Hong Kong, Neurorehabilitation and Robotics Laboratory in CUHK, applied advanced materials and 3D printing technology to develop the next generations of exoskeleton soft robots hand with comfort, lightweight, and better hand function. Okay, so you have 6 minutes. Jumpstart your dream now.
Okay, so I'd like to show you actually is what is wear on my hand, soft robotic. So what's it about? Let's start. If you have a stroke friends and then or parents, you know this so disparate. The doctor will tell you after half years, they will say nothing you can do. This is the hand you got, and just live what you have. But nowadays, with the technology of robotics, no, the things have changed. The robotics can change better motor recovery. And what you can see here is for the stroke, actually it's a leading cause of disability in the world. And there's a golden period for the training. Within 3 months, we should do all this training as much as we can. So you can see in this clinical trainings that we have, but they just can stay in the hospital for 20 days in Hong Kong. And then how about the rest? It's a home-based training. So what we can do, can we bring the training back home? And then that will be more effective. And you can see this is not just Hong Kong problems, it's global challenge. So what we did in Hong Kong, actually, is we developed the robots in 2008. So this is the robot we built. And for the big tower with the wrist, elbow, and knee and ankles, why we build this? Because we want to integrate one important element, human intentions. So if my left hand is affected by stroke, I cannot open my hands, but actually I can detect the intentions from the paralyzed muscles. So we use these myoelectric signals to control the robots. So if I want to open the hands, the robot will help me to complete the task. Then the brain will relearn it. So through our experiments, and we find this very effective. After training for a month, they will learn the task. 3 months later, they come back, the function is still maintained. That's very good. Clients, doctor, everyone's happy. If you just put the robots without intentions, just help them to move, no effect. So we know this is important. In 2012, we moved one big step, make what we have called is a hand of hopes. In the science park here, we also have a company launching this product. It's invented by us. So what it did, actually use the intentions to move these metallic robotic hands. Very useful, very successful, clinical trial, very, very good. And then we licensed to this, we have robotics, and also support Vincent Medical company to list it in IPO in Hong Kong last year. And we also launched this as a service to another company, and later on you will hear his presentations. So this is some of the movie. We can see how the robot hands move. On my left-hand side, you can see it's very difficult to move the hands. Okay, with the robots, they can do a task. But more important is just not moving the hand with the muscles. Is the next one is the recovery. Yeah. So please run the video. So if you have a stroke, then like this case, the left side is affected. Very difficult to do a hand open and close. But after 10 sessions, and we can see a big improvement. So the training is actually in the brain. So this is important message. So what we're going to do is, after the hand, is we do this exoskeleton lower limb. So this is in the market, very expensive, huge, bulky for the spinal cord injury. But we developed this one for this ankle and the knee, very lightweight, and can improve walking upstairs, downstairs. This is all have been licensed. So what, Raymond, you are going to do today is we develop the next generation's soft robotics. You may like the Terminator. This year there's a new movie. With this tissue structure with nano material should be stronger Terminator you can see in the world. So what we're doing in us, we have these exoskeletons. Okay, strong, effective. And we also have, in Chinese U, we have this soft robots, like earthworms, crawl inside your intestine for this screening. It's a bit disgusting, but it works. And how about combine these two? You have the power and you have the flexibility. So this is what we are doing. We have designed this already in our prototypes. And you can see in the movie, and it will work. And what's the nice things? We can see in the next slide is this one. You just can do one task, open and close. You cannot grab a lot of objects. But now, you can see I can grab my microphone. I can do a lot of different things. Waterproof, lightweight, just 200 grams. And the cost, we estimate is around $1,000. Actually, the price and the weight similar to the iPhones. So what we want to do, we want the stroke patients bring the iPhone? No, bring this soft robotic back homes. So they can purchase one for the training, and then they will have better recovery. But the market is bigger than that. You can see they may have in this knee pain, ankle joints, and then we can try different material for the 3D printing. So let's have a quick look on this video. Using a soft robot, this is a real stroke survivor. He can grab the towel, twist the towel, clean himself. Independence. For the metallic robot, we cannot. So thank you very much.
Thank you for Professor Tang. So here comes judges. Do you have any questions for Professor Tang?
Thank you very much for this very interesting presentation. You just mentioned that this is a really new technology for nanomaterials, robotics, engineering, etc. But how about the reconditioning, the training part? Do you have any sort of different methodologies or training programs inside this system so that different patients will have different training platforms or training programs for different peoples, because they're individual, right? The illness could be different, the damage to their muscle to whatever, right? So how does that work in terms of software side?
Yeah, thank you, Peter. Actually, what's happening is we know about this metallic robotic, and then we know how to do the training. But we also did one interesting experiment. If the training is with a task-oriented, with different hand function tasks, actually we find the recovery is much better. So if we have this soft robot hand, we know what's the disability of the patients. Maybe it's grabbing a cup or maybe grabbing a coins. Then we can do those training. And then we expect the recovery will be much better than just simple hand open and close with the robot hand. So actually, we have a program already embedded in our system. So we will tailor-make. So the robot hand is you cannot buy from off the shelf. You will go through the doctor and the physicians to do that.
How close is this technology to commercialization? Because I saw in one of your previous slides, you also had a previous version that was out in 2012. Were you able to bring that to market, or I mean, what is the commercialization?
So this one, actually, this is already prototyped. In our experience, once the prototype has been launched and tested on the stroke patients, and then it takes about 3 months, we can already transfer the technology. So within the end of this year, actually, if the company is interested, we can transfer technology. So that's what we did in this metallic robot hand.
For the 2012 version, that was also prototype, right? Were you able to bring that to market?
It's already in the market, this one. It's already in the market, and then they sell over 15 countries and more than 2,000 patients using this one worldwide. And then, but this is 2012, and then, but this one is brand new. We just built this 2 months ago, and then we just test it out. But I think the royal plan is by the end of this year, we're able to launch it. But we need more funding, more bigger scale to do that. Same price as I mentioned in the previous slides, just like your iPhone. How much is the iPhone sell? We will sell that price, So actually, this is a tailor-made hand because our fingers is different length. So we tailor-make because this all is using the 3D printing to print the soft material. Inside they have different chamber or this component to make the movements, okay? And so the price actually is around 7,000 Hong Kong dollar, around $1,000 US. That's our same price. So it's definitely much cheaper than this one. So we want to each patient have one back home for the training.
Right. Do you have customer support?
Yeah, we need to have those service supports together. So, and that's not difficult because the clinic already provide those training and service. So we will join forces together with those clinics. They will provide the training and the service. We provide the technology.
Thank you, Professor Tang.
Okay, thank you very
Thank you,
much.
judges.
Have a nice afternoon.